Morning and welcome to Calculus in the AM. I'm your host, Mr. Shindelka. And today's lesson has been brought to you by Alabaster 9 Developments Limited, subsidiary of Creole Point Manufacturing. Joel Shindelka, sole proprietor, 1-306-782-21453, extension 7, by appointment only. Now, we're combining rules. You know, so here's an example in everyday life where you combine rules. Sit down, shut up. 2 rules, follow. This one, which rules would we use here though? It looks like, right off the bat, you see this. What's the first apparent rule that you see? Quotient rule. Okay. Within that though, do you guys see quotient rule and chain of fools. And you know it is a chain of fools because you guys are foolish enough to take calculus. dy by dx. I am actually going to color code this though, just saying that, because it gets confusing. Red for the top. Actually, I'll just, if I try to type it, I'll just rewrite it with new colors so you can follow my rule. 2x cubed, I'll do in red. Outside function, I'll do in green. Inside function, I'll do in blue. Make sense?
Yeah.
So, here's where it gets slightly confusing. And basically, all the questions that you have left on that sheet, hand it back, is a combo of rules. Do the derivative of the top, leave the bottom all alone. So the derivative of red, 6x squared. Now you guys stop me if I make a mistake, because then if you don't know what I'm doing, I might have made a mistake. The bottom times the bottom, left alone. I am just, right now, I'm applying the quotient rule.
Okay.
And I'm doing the derivative of this part of the expression, which doesn't involve any chain rule. I wrote down the bottom as exactly as it was. So I haven't done any derivative to the denominator's expression yet. That's actually the next thing. Top left alone, 2x cubed. Derivative of the bottom expression. So I see that green, that's the outer, and here's the chain rule. So I bring down the 4. Tell you what though, I should, if I'm going to have another number beside this number, I'm going to have another bracket here. I'll do it like this. I don't usually use square brackets. I don't. It's on the bottom. But the derivative of the outside function, would you guys agree with this? It doesn't really matter because you leave the inside alone for the first part of that. Chain rule, right? Times the derivative of the inside. And in this case, 4x minus 1's derivative is 4. Oliver, twist, the bottom, up. I'll keep my color coding. Now, I'm going to square that. Let's see. So, I'm going to go with 8. So I've squared the bottom, right? Never multiply out the bottom unless you got some kind of crazy hunch that you need to. I'm going to pause for a second here and you double check math and then we'll try to simplify something here. Okay? So we'll do a little bit of factoring here. I'm going to drop the color scheme. So why don't we multiply? Oh, you said multiply. That's pretty tough multiplying, right? Because that's to the power of 4. You'd have to go 4x minus 1 times 4x minus 1. Right. Let's pull out a common factor of 4x minus 1 to the highest power. What? To the 3. Then we'll pull out a common factor. Is there a number that's in common everything? and then I was gonna say, and the letter, the highest power is x squared. So I'm gonna go 2x squared, comma, 4x minus 1, common to the power of 3. I'm gonna yank that out of everything. Now, keep in mind, and I'll do this in black behind here. You don't normally, but I want you to keep this in mind. You're really multiplying by 1 when you're factoring, right? 2x squared. I'm putting it behind just because I can fit it here. Okay. Why did I do that? Because I want to remind you, how did you get this 2x squared out in front? And actually, I'm going to erase it just because I want to be able to scooch things around. Let's see what I mean. Clone that. Sorry about taking your sweet time. Now, do you guys agree on the first step where I wrote that's just multiplying by 1, right? This is how you got this out in front, then, right? Then you kind of think of this as being distributed. I'll divide the first part of the expression by this, right? Then I'll divide the next part of the expression by that. I'll keep the power of 8 stuff down just as is, right? Okay. Now, do you guys follow me on this? Can we see if you can do that, and then we'll match answers and see if we have matching answers. It's easy to make a mistake. Okay, so hopefully I had something like this. Hopefully I have it correct. Before I go too much further, 4x minus 1 cubed on the top, 4x minus 1 to the power of 8 on the bottom. We can clean that up, right? Power of 5. See that? Never multiply those brackets out because we're factoring anyways. So that can be done at your last step. It doesn't have to be done at this step, right? I'm just choosing to do it now. Now I got my 2x squared. I got 3 times 4, so 12x minus 3. I'm going to write it out. I was going to just do it all in my head, but I know us. I make mistakes, you make mistakes, we all make mistakes, except my wife, she's perfect. It's 5. That's a terrible exponent there. Just scooch that in here better. Okay, and then you group like terms here, right? Do we get negative? Minus 3. The last thing you could do is then pull out the negative sign in that. And have 4x plus 3. Is that right? So the negative 4x minus 3, I yank that out. Okay. So I'll do a quick scan. I've rewritten the problem red, green, blue. Primary colors. Now, what do we got here? Rule-wise. Product rule and? 2 rules. Sit down, shut up. Right. Okay. I'm going to use f prime of x as a notation. That's not a big deal. If you actually put down y prime or something like that, I'm not going to freak out. But do write down that you're doing a derivative somehow. And if you have a problem where you consistently write down the wrong thing, dy by dx, when I give you f of x or something like that, I'll start needling you. If it's the odd careless time, well, whatever. Anyways, product rule. Take the derivative of the first thing, leave the second thing alone. Plus, leave the first thing alone, take the derivative of the second thing, right? So we'll work on this first step. you guys do it, I do it, we'll see if we have matching steps, okay? Ta-da! Because I just started the video. Take a look, compare answers. Hopefully you paused and actually did it, and you're not just looking here and copying it down. But let's explain. The derivative of the first thing, 2x plus 3, is 2. I didn't change a thing on the second thing. Product plus, built in. First thing left alone. The rest of this is the derivative of the second thing. So I bring down the exponent, that's the 1/2 in front. Leave the inside alone, subtract 1 from the exponent. Negative 1/2 comes out. Did anybody forget the derivative of the inside? 5? You guys are like Cracker Jacks. Notation thing. I'll get grumpy about some things. People sometimes, when they have a number in the middle of the expression, they forget to put the bracket around this. Don't just put down 1/2 there in the middle. Especially if it was a negative 1/2. It looks like, then it's truly wrong because it looks like you're subtracting. Okay? Use brackets. Throw them around like salt and pepper, you know. Now, after this, you can probably see where to go with factoring. You've got 5x minus 1. Take the lowest, so negative 1/2. I'm going to drop the colors. 5x minus 1 to the negative 1/2. Is there a number in common? Not really. But what about that fraction? Typically, when you factor things out, you don't leave a fraction inside. How do you get the 1/2 out? Well, let's just think about multiplying things by 1. I think we understand the 5x minus 1 part, so I'm going to just take the original expression, maybe scooch it in a bit here. I'll pause here just because that's mechanical. So as we were saying, I just start the video again. To get rid of that 1/2 there, I need to multiply it by 2 and I'll get rid of the denominator. But I can't just say multiply everything by 2. I got to multiply by 1 in the form of 2 out of 2. Right? Now this is usually done as a thinking step when I put it at the back there, right? Now, this time, what am I going to distribute? I'm going to distribute the 2 to this group here and it'll cancel out with the 1/2, right? And then I'm going to distribute the 2 to the front chunk and it'll become 4. Everybody agree with that? And that out of 2 will stay there. This, I'm going to distribute to here and here, right? You guys see? So really, my factor that's out in front in this next step is out of 2. You guys follow me? There you go. There we are. If you are feeling ill, contact Alabaster 9 Productions. It's a mystery what they do. I work there, I don't know what to do. Okay? Just so that we have the skill of the out of 2 or whatever, right? If I say, in this expression, get rid of the fraction, factor it out. Like, so I say, well, 2. 2. That's legal, right? I'm multiplying by 1. So really what I'm thinking of is I want to distribute, oh, I took steps, I thought for sure detach. Anyways. There. Now it'll detach. Sometimes this board just glues things together. So do you see that if I distribute this 2, it'll become 1. Then I distribute it to here, it becomes 6. Okay, so with an easier expression, it's, I'm going to move this out front, the 1/2 is left behind because I'm throwing the top 2 through, right? 6. Delta, 6x plus 1 in this case. Do you agree that that is the same expression? Okay.
So would you only do that with fractions? If there wasn't
It's sort of like upside down factoring in a sense, that you're leaving the bottom outside. Some people like to think of this way. I'm just showing you a different way. Some people have a devil of a time just thinking of it as I'm pulling out and dividing by 1/2. But you can think of it as dividing by, like factoring out 1/2. Because when I factor out a half, what is 2 divided by a half? 4, I hope, right? It's the same result. It's just 2 different ways of thinking, and I want to show you a different way, if it works for you. Now, I'm going to erase this example here. That was just a... If it's working better for you, is it?
I don't know yet.
Well, we'll see. Either way you're thinking of it, I'm multiplying this 2 through here and here, right? Or I could think of it as I'm factoring out a half. I'm dividing by 2. Dividing by half, I'm sorry. Everything. Either way, what happens here? If I think of it as multiplying by 2, I get 4. If I think of it as factoring out a half and dividing by half, I get 4, right? So I'll drop the colors. 4. What about the 5x minus 1 to the positive half? Ouch, right? So now I'm thinking, this part here. What is this, 5x minus 1 to the positive half, divided by negative half?
Just one.
Power of positive 1, right? So 5x minus 1 to the 1 plus this is canceling out if you think of it this way. Or if you think of it as half divided by half, it's 1, right? So I've got no junk there. 2x plus 3. The half cancels out. I factored out 5x minus 1 to the negative half. I only have the number 5. I think from here it's manageable, isn't it? We'll each tidy up for a second and then that's it. We'll compare answers. For those of you on the internets, this is my answer. I'll just mention some things. Hope you realize negative exponent means flip it downtown, and the half is the square root. My group-like terms, did I do anything incorrect?
Yes.
Yes, I did?
Negative 4 plus 15.
15 is 11.
Yes.
Thank you much. I saw it as you said it. Great stuff. I do make mistakes. Okay, over and out.